Okay, so let's start dimension today. Angelina,
Yes, sir.
suppose I'll ask you, what is your identity proof? Then what you will tell?
So my name is Angelina.
Identity proof. What document you submit for identity proof?
So date of birth.
Document. Document means what?
Aadhaar card.
Yes, Aadhaar card. Okay, so Aadhaar card is your identity proof. So one number is given to you, so that is your identity. Suppose I'll tell you only Aadhaar card. Is there any identity proof you have? Anybody can tell me?
Sir,
Do you have
what certificate?
Do you have school ID?
Yes, sir.
Do you have any school number?
Class 10 mark sheet. Class 10th mark sheet.
No, identity proof. That is not identity proof. Okay, identity proof means your photo should be there, right? And you have one identity number, which number is only your identity. That must not be given to anyone else. Understood? Identity proof. Your Aadhaar card is identity proof. Your school ID card is one identity proof, right?
PAN
So all
card.
these are PAN card also can be identity proof. PAN card photo is there also can be identity proof, right? So identity proof. That means you have one Aadhaar card number, which number is your identity. That must be some digit large number which is not given to anyone else in all over the India or not. Similarly, physical quantity also they have some identity. So what identity physical quantities has? They have two identities, just like you told that Aadhaar card is one identity, school ID card is one identity proof. Similarly, all the physical quantities what we have read earlier, many physical quantities you know. So all these physical quantities, they have also identity proof. What are the identity proof of the physical quantities? One is what? Unit. Unit is one identity proof. Another one is what we are going to discuss today. So that is dimension. Then the question is coming to your mind, sir, how unit is the identity proof of the physical quantity? You see, suppose I'll tell you Newton. Newton is the Newton. If you just listen Newton, then immediately you can guess about which physical quantity I am going to tell. Which physical quantity?
Force.
Force. Because force means Newton. So Newton is the identity of the force. Suppose I'll tell you joule. Which quantity, about which quantity I'm going to tell?
Energy.
Work.
What?
Work, energy, they almost all are similar. So they have this identity. So unit is one identity of a physical quantity. Newton unit is not given to any other physical quantity, right? Similarly, dimension is also one identity. For example, I'll tell you, suppose 1, 1, minus 2. What is this 1, 1, minus 2? These are all just simple numbers or not? They're simple numbers. Okay.
Yes.
But this 1, 1, minus 2 is the identity of a quantity. And what is that quantity? What the quantity? Force.
Force.
You don't know all these things. We'll discuss today. So force has the identity 1, 1, minus 2. If I'll tell you just 1, 1, minus 2, you can able to understand that sir is going to tell about what? About what?
Force.
Force. If I write 1, 2, minus 2, then immediately you will understand about which quantity I'm going to tell.
Pressure.
This is work or energy, right? Work, energy. So these numbers are identity of the physical quantity. So now I think you understood. You have two identity proof. Similarly, physical quantity has how many identity proof? How many? Physical
Two.
quantity? Two. One
Sir,
is,
unit
other one is,
Sir,
dimension.
Dimension.
but about unit you all are acquainted and already we have discussed. Over
Yes,
that is
yes,
unit and the dimension chapter. About unit already we have discussed. Okay.
Yes.
So now we'll discuss about the dimension. But one question is must come into your mind. Sir, how you know that this force has this identity? How you are getting unit that you know, but how you know, sir, work has this number of identity? So that one now I'll tell you. Just within 2 or 3 minutes, you can able to understand. Also, you can able to easily find out these numbers. It's not very difficult, very, very easy. If I just teach you the trick, within 2 or 3 minutes also, you can able to find out the numbers like this. Okay, so let's see how can you get those numbers. But before that, one thing, one at least you should have the idea. What idea you should have? You all must have the idea of fundamental quantities. Fundamental quantities, all should have the idea. So all of you know the 7 fundamental quantities? Remembered or not?
Yes, sir.
Yes.
7
Yes, sir.
fundamental quantities in physics. What are the 7 fundamental quantities? One by one, please tell me.
Length, mass, time, electricity, thermodynamic temperature, amount of substance, luminous intensity.
Yes, mass, length, time, then thermodynamic temperature means it is presented as a K, Kelvin. Its SI unit is Kelvin. So that symbol you will take as a K. Then current, for current SI unit is what?
Ampere.
Sir, ampere.
That symbol will take A. And amount of substance,
Mole.
amount of substance,
Mole,
that is
mole.
mole. That symbol will take mole, MOL symbol will take. And luminous intensity, that is not required. Candela, that is luminous intensity. Its SI unit is candela, luminous intensity, right? Its SI unit is candela, CD. Okay, so these are the fundamental 7 fundamental quantities, and you should have the idea about the 7 fundamental quantities. All of you have to remember the 7 fundamental quantities. You have to mug up, otherwise we can't able to understand what is dimension. Is it clear? I hope all of you
Yes,
remember the 7 fundamental quantities now.
Yes, sir.
Yes.
Complete. Okay. Once you write in your copy, mass, length, then time, temperature, Kelvin, electric current, ampere, amount of substance, mole, the luminous intensity, candela. In a copy, you write these fundamental quantities, and you have to mug up the 7. You have to remember the 7 fundamental quantities. Then we'll go to the dimension now. You see how we'll find the dimension. So dimension, what numbers I just wrote, force 1, 1, minus 2, but how you will get those numbers? Suppose I'll tell you now, one quantity, suppose speed. Speed, suppose. Okay. What is the formula for speed?
Sir, distance by time.
Distance by time.
Distance by time. Speed is equal to distance by time, right? So speed is V. Then distance means its length. Is it fundamental?
Yes, sir.
Yes, sir.
It is
Yes, sir.
fundamental. So it is L1. Time,
Yes,
is
sir.
it fundamental?
Fundamental.
Yes,
sir.
So time means that is T1. So now it become L1 T minus 1. And I have to put in bracket like this. Now see, what is called a dimension here? What I did actually, I convert the speed into which quantities?
Fundamental quantity.
Fundamental
Sir,
quantity.
fundamental.
Any quantity dimension you want, you just convert the quantity into fundamental quantities. Now in the formula, all should be fundamental. Now in the formula, all are fundamental or not? All are fundamental.
Yes, sir.
Then you
Yes.
write like this. Okay. So here what happened? Now we got a formula at last. I wrote it inside square brackets, right? So this is called a dimensional formula. This is called a dimensional formula. Then what do you mean by dimensional formula? It is a formula which tells us, it is a formula which tells us how and which fundamental quantities are used to express the physical quantity. How and which fundamental quantities are used to express the physical quantity. Which fundamental quantities are used? The length and time. How they are used? As the power like this to express the physical quantity. So this is called a dimensional formula. Again, I repeat, dimensional formula is the formula which tells us how and which fundamental quantities are used to express the physical quantity. Hope everybody remember dimensional formula. Okay, but what do you mean by dimension? These powers 1 minus 1, these are called as dimensions. Which powers?
1 and
powers-
minus 1.
1 minus 1.
The powers of what?
Sir, the
The-
fundamental quantities.
Fundamental quantities.
Powers of the fundamental quantities. Powers of the fundamental quantities are called as the dimensions. They are called as the dimensions. So what do you mean by the dimensions? Dimensions are the numbers, or dimensions are the powers. So dimensions are the numbers to which the fundamental quantities are raised to express the physical quantity. Again, I repeat, dimensions are the numbers or powers to which fundamental quantities are raised to express the physical quantity. Means what numbers just before I told you. So I also got the numbers like this. Here, this 1 and minus 1, they are called as the dimensions. They are called as the dimensions. And dimensions are written in which brackets?
Square brackets.
Square bracket.
Sir,
Common bracket. Dimensions will write in common bracket, but dimensional formula will write in
Square
Square
bracket.
bracket.
square bracket.
square bracket. But we'll write 1 minus 1 in length and time, but respectively. 1 minus 1 in length and time, but respectively. We have to write it like this. Understood? Respectively. Why? We will write respectively like this because there are many, there are 7 fundamental quantities. So particularly which fundamental quantity we have used, that one we have to mention properly. 1 minus 1 in length and time respectively. Okay. So these are called dimensions. Then what is the dimension of speed? Can anybody tell me? What is the dimension of speed?
L1 T minus 1.
Sorry, L1 T minus.
Dimensions. My question is dimensions of
1
what is the
minus
dimension?
1
1
in
minus-
length, time respectively.
Good. 1 minus 1 in length and time respectively. But what is the dimensional formula for speed?
L1 T minus 1.
L1 T minus.
L1 T minus 1. Okay, then within square brackets. This is the dimensional formula and this is dimension. Okay, let's find another dimension. Suppose I'll find the dimension formula for this is speed for acceleration. Suppose speed and velocity, they both have same dimensional formula, same dimensions. Let's find for acceleration. Okay, so acceleration. But before finding dimension, you should have the knowledge about the formula. You should know the formula, otherwise it is not possible. So acceleration equal to what?
Velocity by time.
Velocity by time. So this is acceleration, right? Is velocity fundamental?
No.
No, sir.
No, sir.
Then if If not fundamental, you have to convert into fundamental. You have to put the formula. We have to put its
Length.
formula. Then what is the formula of velocity? Yes,
L1 T minus 1.
displacement by
Displacement by
time.
time.
First you tell me formula, displacement by time, then this is time. If you write the symbol s by t, okay, then it become s by t square. Am I correct? Or any problem you are facing? Is it right? Everybody understood?
Yes, sir. Yes.
Yes, sir.
Okay. Is this s fundamental?
Yes, sir.
Yes, sir. Length.
Which fundamental quantity this is?
Sir,
L,
length.
Length.
L1. Time is fundamental.
Yes, sir.
Yes.
Okay. When all will be converted into the fundamental quantities, then our job is over. Only we'll check the powers. What is the power of t?
Minus 2.
Minus 2. Now you got the oscillation dimension. What is the oscillation dimension? Who can tell me the dimension of oscillation?
1 comma minus 2.
1 comma minus 2.
1 comma minus 2. Only if you tell, then this is wrong. 1 minus 2. Again, 1 minus
Respective
2
minus 2
Length and time
respectively.
in length and time respectively. And this is called dimensional formula. Let's find the dimensional formula for another quantity. Suppose that is force. Let's find the dimensional formula for force, suppose. If any doubt anybody have, you can ask me, no problem. Huh? Dimensional formula for force, suppose. Force is equal to mass into what? Acceleration.
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 Okay. So is mass fundamental?
Yes, sir.
Yes.
Yes.
Yes, sir.
Is acceleration fundamental?
No.
No,
No,
sir.
sir.
Then acceleration we have to convert. Acceleration formula is velocity by time.
Yes.
Okay.
Yes, sir.
Is velocity fundamental?
No, sir.
No, sir.
No, sir.
Again we have to use the formula of velocity. Velocity is displacement by time. So now it is coming ms
sir.
by t square. Now is mass fundamental?
Yes. Sir.
Yes, sir.
Yes. Sir.
Yes, sir.
Is distance fundamental?
Yes,
Yes.
sir.
Yes, sir.
Is time fundamental?
Yes, sir.
Now work over. Okay, only convert to fundamental. Then mass symbol is m1 and the displacement L1, then t to the power minus 2. Now over. Which formula? Dimensional formula it is.
4.
Force.
Now tell me the dimensions of force.
Sir, 1 minus
1
2
comma
of
1
minus
comma
2,
minus
length
2
and time
Then
respectively.
length,
mass and time.
mass, length, and time respectively.
Understood? 1 minus 2 in mass, length, and time respectively. So this is the dimensional formula for force. 1 minus 2. Hope everybody now understood how to find dimension. Just before I wrote this number, and I told you this is the identity of a force. Whenever in physics you will write like this 1 minus 2, then everybody will understand this is force. Just like your Aadhaar card number. Wherever you may go, your Aadhaar card number, anywhere you type, automatically your photo and everything will come out. Or the person can check your identity, whether this person is the right person or not. So similarly, all quantity have one identity number. This is the identity number. Okay. So there are around 94 quantities are there in your NCERT book in the last page of the part 1. If you have the part 1 book with you, you can open to the last page. Not completely last. From the last, you just leave 4 or 5 pages. Then see, there you will get how many quantities are there?
94.
94 quantities are there. So you have to find out the dimension of the 94 quantities, but for practice, I am telling. For your practice, you should find out all the 94 quantities. But the question will come to your mind, sir, in these 94 quantities, only few quantities are very familiar to you. But around you'll see 30 quantities or 20 quantities will be familiar to you. But around 70 quantities, they are totally new for you. You may not know those quantities. If you do not know what you will do, nothing. Can anybody help you? No. Then because if you don't know their formula, then how can you find their dimension? You don't know their formula. And if you tell, no sir, first we'll try to understand all the 94 quantities, then I will find the formula. And when you will understand the 94 quantities, and to understand the 94 quantities from the last page of the NCERT book, it will take 2 years. When in these 2 years, when your 2 years of physics will be over, then all the 94 quantities will be over. So don't worry about that. You see the formula from the book. I think in that page, the formula is also given.
Yes, sir.
Okay, formula is given there, right? Okay. Suppose one example I am telling to you. Many quantities are there. Any quantity you tell me from that, if you have the book which you don't know, for first time you are listening. Any quantities there?
Coefficient of viscosity.
Yes, coefficient of viscosity. What formula is written there?
ml t minus.
Formula, tell me. It's a formula. I'm not telling dimensional formula. It's just formula, tell me. Coefficient of viscosity. Is there any symbol given? In the book? For coefficient of viscosity? Okay. Anybody tell me if you're getting that coefficient of viscosity?
Yes, sir. Force by area into velocity gradient.
Yes, tell the formula.
Sir, force by area into velocity gradient.
Force by area, then
Whole into velocity gradient.
okay, then velocity gradient, right? Okay, I'm writing the main formula from where actually it comes. It comes from here. This is actually the main formula. Okay, from the main formula, then eta is equal to FD by AV. FD by AV. Right? So this is actually the formula. Okay, main formula, this one. So from the main formula, we got through this. But actually, you don't know what is coefficient of viscosity. And don't try to understand also what is coefficient of viscosity. Don't try to understand. Why I'm telling? Because this one you will understand in the particular chapter that's called as fluid. If I tell you now, then also you can be able to understand what is this coefficient of viscosity. Okay, when you go the chapters one by one, time will come and you will automatically understand. But now only for this chapter, you don't try to understand what is coefficient of viscosity, but try to understand what quantities are written here. What quantities are written here? Whether you understand these quantities or not, you check. This one you know.
Yes, sir.
Sir, what is velocity gradient?
Velocity gradient actually V by D. That also you don't know. That's new for you. Okay, that is actually V by D. Velocity gradient, right? So this quantity you know. Force.
Yes.
Okay, it's a dimension we put just before we found its dimension M1 L1 T minus 2. Am I correct?
Yes, sir.
What is G? D is the distance. Okay, so this is L1. What is A? A is area. Area dimension will be what? Length into breadth. For the dimension?
L2.
L2. Then this is V. V is speed or velocity. What will the dimension? Yes. Speed.
L1 T minus 1.
L1 T minus 1. You can put the dimensions like this. Then solve it and tell me what at last you are getting. Finally, what you're getting, tell me.
Sir, M1. Sir, then L minus 1.
Yes.
Sir, M1, L minus 1,
T minus
T
1.
minus 1.
Okay. Is it given in the NCERT book, same thing? NCERT book, you see? What is given there?
Yes, sir.
Is it given? Same.
Yes, sir.
M1, L minus 1, T minus 1.
Yes.
Okay. So now in this way, you have to find out the dimension. In this chapter, your purpose is only you try to understand what quantities are there in the formula. But what is a quantity, you can't able to understand in this chapter, because if you understand the whole quantities, then your 2 years of physics will be over, right? Okay, only in one chapter we can't able to understand. But when the particular quantity will come, again we'll find this dimension of this coefficient of viscosity. Where? In its corresponding chapter, in fluid chapter. Just for this chapter we are getting. But one question is must come into your mind. But sir, in school exam, if this quantity will come, then what will you do or not?
Yes,
Suppose
sir.
one quantity you don't know, school exam, the question will come. No, listen. All teachers also know this fact. You can't able to remember all the 94 formulas. They will not give any quantity which you don't know. If they will give any quantity in exam, then also they will give the corresponding formula to you. Okay, they will give the formula. But my advice is don't try to mug up the dimensional formula. There is nothing to mug up in physics. That's why don't try to mug up the dimensional formula. Okay, don't try to mug up. Only some formulas by practice, if you can able to remember automatically, then it's okay. But don't try to mug up any dimensional formula. It's not at all required. So these are the dimensions. How can you find the dimensions? I show you. So you can find all the 94 dimensions for your just practice. And if I'll tell you another quantity, suppose I'll tell you charge. What is the formula of charge? You know in lower classes, this formula.
Yes, sir.
Yes, sir. I
I
equal
is
to
equal
Q
to
by.
Q by T. Then what is Q? Q charge. Then Q is how much? Q is equal to what?
Sir, IT.
IT.
IT. Is I fundamental?
Yes, sir.
Current fundamental. Is time fundamental?
Yes, sir.
Yes, sir.
Yes.
If I fundamental, it's a symbol I told you, current A1.
Yes, sir.
Yes, sir.
Time symbol is
T1.
T1. So then what is the dimensional formula for charge? Now you got it.
Yes, sir.
The dimensions are 1 and 1, 1 and 1 in
Ampere
In-
and time. Ampere and time respectively.
ampere and time respectively. Okay, or in current and time respectively. Right? So these are dimensional formula for charge. Why I do this? Because also inside the bracket, ampere like a quantity also can enter. Ampere also can enter inside the bracket. Okay, got it?
Yes, sir.
Another quantity dimension I'm telling to you. Universal gas constant. Have you heard this word? Have you heard about this quantity? Or first time you're listening? In chemistry, it is taught to you. Universal gas constant. Anybody? First time you're listening?
Yes, sir. Gas constant.
Universal gas constant. First time you're listening, I think. Is it? Huh? Universal gas constant. Tell me. Okay, you are listening for first time, no problem. See, from this formula you will get. Formula will be given to you in exam. In exam means now which exam will be conducted in school. But when in school, in the final examinations, if this formula you already know, then the teachers will not give you. Okay, already through when the time will pass, then you will know the formulas one by one. You will understand everything, no problem. So R equal to PV by NT. This R is called as gas constant. This R is called as which constant?
Gas constant.
Gas constant. We will find the dimension of this gas constant. It's a very long dimension formula. P is pressure. What is the pressure dimension? We'll put directly. Can anybody tell me the pressure dimension? Otherwise, see the inside the book and tell me now.
Sir, M1 L minus 1 T minus 2.
Okay, this is force by area. M1 L minus 1 T minus 2.
Yes, sir.
If you will find 10 to 20 dimensions also from your own memory, then automatically you will have a practice. Okay, to get the dimensions. Then this is V is volume. Volume dimension, length into breadth into height. So all are length. What's the dimension?
L3.
L to the power 3. N is number of moles. So now mole enter inside the bracket. That is a mole, number of mole. So MOL, that is mole. What is T?
Time.
Temperature. T not time, T is
Temperature.
temperature. T is temperature, so dimension will be K1, Kelvin, K1. Now you see, M1, L2, T to the power minus 2, mole to the power minus 1, K to the power minus 1. I think this is the longest dimensional formula. Now you learned. Okay. How many fundamental quantities are inside the bracket?
So
How
5.
many?
5.
5 fundamental quantities are inside the bracket. Then 1, L2, T minus 2, then A, mass, length, time, amount of substance, temperature. 5 quantities are inside the bracket. Okay. So this is the dimensional formula. Like this, you have to find out. And what is this gas constant? That you will understand in its corresponding chapter. Okay, but we understand the quantity, then we proceed. So next is we'll discuss about like this. You can able to find out the dimension formula or not.
Yes, sir. Yes, sir.
Now you all have the confidence. You can able to do, no problem.
Yes, sir.
Okay.
Yes, sir.
Okay. Okay. So next we'll see now principle of homogeneity. Principle of homogeneity in dimensional formula. This is one new thing, principle of homogeneity for you. What this principle tells, what the statement of this principle, it tells in a correct relation, dimension of each term are same. In a correct relation. Okay, if a relation is correct or in a correct relation, if the relation is correct, then the dimension of each term are same. That means you have to understand. Suppose I'll write A is equal to B plus C. A is equal to what? B plus C. Okay, how many terms are here in this equation?
Sir, 3 terms.
3 terms.
3 terms. This is one term, this is one term, this is one term. Suppose this relation is a correct relation. If this is a correct relation, then principle of homogeneity tells each term dimension is same. Each term means A dimension will be same as B dimension, will be same as what? C
Yes,
dimension.
sir.
All will have same dimension. Okay. Obviously, they will have same dimension. How? See, suppose this A is a length, then B is length and C is length, because length plus length equal to length, no? Or not?
Yes, sir.
Yes, sir.
Newton plus Newton equal to Newton. 5 Newton plus 3 Newton, you will get 8 Newton. Okay. If this is Newton and it is added with this quantity, then this must be Newton. Otherwise, how can you add? Suppose I will tell 5 Newton plus 10 Joule. Can you able to add?
No, sir.
I'll tell
No, sir.
2 kg plus 3 liter equal to how much? 2 kg plus 3 liter. 2 kg rice plus 3 liter oil is equal to how much? Possible?
No, sir.
No,
Not
sir.
possible. Okay. So if 2 terms are added like this, then they must have same dimension, and also the result also will have same dimension. Their units are same, that's why dimensions are also same. This is principle of homogeneity. In a correct relation, dimensions of each term are same. One example I am telling to you. Suppose V is equal to U plus 80. Have you heard about this relation?
Yes, sir.
Are you sure it is correct? Are you sure it is correct? You have read in class 9th?
Yes, sir.
Correct. If you correct, now I'll check whether principle of homogeneity works or not. How many terms are here?
3, sir.
3 terms. So first term V dimension is what? This is speed. So dimension is L1 T to the power
-1.
The minus
minus 1. Okay. U is also velocity, initial velocity. What is the dimension?
L to the power 1, T to the power -1.
L1 also T to the power minus 1. Then 80. Acceleration into time. Acceleration is L1 T to the power minus 2, and this is T1. So at last we are getting L1 T to the power what? Minus 1. So also it is correct. So now you check the 3 terms. Three terms are here now. You check the three terms dimension. Are they equal?
Yes, sir.
That means principle of homogeneity now is tested. Okay, if a relation is correct, and we know this relation is 100% correct, so each term has the same dimension. So it is a now correct relationship we got. So next we'll see this principle of homogeneity. We can say also is another way. There is another statement of principle of homogeneity. What another statement principle of homogeneity has? Next statement is, in a correct relation, if two terms are added, or simply we can say tell like that, if two terms are added or subtracted, then they must have same dimension. If two terms are added or subtracted, then they must have same dimension. You see here, these two terms are added or not? B and C.
Yes.
Yes, sir.
Then they must have same dimension. Okay. If two terms are added or subtracted, they must have same dimension. Obviously, because if two terms are added, they must have same unit. So their dimensions also will be same. Okay. Wherever you will see in any quantity, any relation, if two terms are added, they must have same dimension. Okay. This is also another statement of principle of homogeneity. We saw here B and C both have same dimension. Okay. So using this principle of homogeneity, we can do also many questions which always comes in exam. Always the questions comes in exam. Let's do a simple question based on this principle of homogeneity, which always comes in exam. X is equal to A plus BT plus CT square. Keep your pen ready. X is distance. X is distance. And T is time. T is what? Time. So question is, find the dimensional formula of A, B, and C. This is the question. Find the dimensional formula of A, B, and C. Please try. So hope all of you completed the answer of this question. Those who have completed, you check now. Okay, whether you have done correctly or not. So dimension of ABC is asked here. X dimension you know, because X is what? What is X?
Distance.
Distance. So its dimension you know, X is equal to L1. If X is equal to L1, then you can find the other dimensions easily. How other dimensions? Now you say A. X and A both are, if X dimension is L1, A is also another term. According to principle of homogeneity, also A dimension will be
L1.
L1. Why? Because principle of homogeneity tells each term has the same dimension. Each term has same dimension. So A dimension is also L1. Because same. If X is L1, then A is L1. Then BT. BT is one term. Combinedly, that is one term. Then BT dimension is what? Also that is L1. BT is L1. But we need what?
Time.
We need B. We need B dimension. So that is L1 by T means L1 T minus 1. Now we got B dimension. We got A dimension. Okay, then what is X dimension? That is also CT square dimension. Same. Then tell me CT square equal to how much?
Sir,
L1.
LT minus 2.
Sir, LT
CT
minus
square is L1. CT square is L1. CT square dimension is what? L1.
Sir, L1T minus 2.
L1 T minus.
I am telling CT square dimension is L1. Understood my point? C into T square is L1. Then what happens to C? C is equal to L by T square. So L1 T to the power minus 2. This is the dimension of C. Correct?
Yes, sir.
We got. It's a very, very important question. Always comes in exam. L1. If anybody has any doubt, then ask me. Yes. Please ask me if you have any doubt. This term dimension equal to this term dimension equal to this term dimension equal to this term dimension according to principle of homogeneity. So that's why A is equal to L1 X, BT is also same as X. CT square also same as X. Then I do little bit mathematics. Then we got it. It's a 1, 1, 1. This question can come as a 3 marks question. Another most important question, which always comes in exam, whenever you open any question paper of class 11, you must get that question. Okay, so let's do that question. P plus A n square by V square whole into V minus NB equal to nRT. Okay, P plus A n square by V square whole into V minus NB equal to nRT. Have you seen this formula? This formula is called as which formula?
Van der Waals constant.
Van der Waals gas equation. This is called Van der Waals gas equation. You will read that in chemistry. Don't worry about this. But we need only the formula, and we have to understand all the quantities one by one. Okay, P is pressure, A is a constant, N is number of mole, and V is volume. V is volume, N is number of mole, V is a constant, N is number of mole, R is gas constant. Just before we found a gas constant. T is temperature. T is temperature. All are related to gas. Okay, pressure, volume, temperature, number of mole. Then the question comes in exam, find the dimension of A and dimension of B. How will you find the dimension of A and B? Very, very important question. Okay, very, very important. Please try this question. Okay. So those who have completed, now you check whether you are correct or not. See, V is subtracted from NB. It's a very, very important one. Huh? You must practice this question at least 3 to 4 times. V is subtracted from NB. So V dimension is same as NB. So imply that B is equal to V by N. But you don't write V is equal to NB. You write V is equal to dimension of NB. Write like this. So B is equal to V by N. What is V? What is V? I told you just before.
Velocity.
I told you just before.
Sir,
This is
volume.
B
Sir, L.
volume. L to the power 3 volume. This all are gas related quantity. L to the power 3 mole to the power minus 1. So this is B. Okay, done. Then A how will you find? Achha, P is added with A n square by V square. Then P dimension is same as A n square by V square dimension. Then what is A? A is equal to PV square by N square. Right? PV square by N square. Okay. Any doubts? Their added means their dimensions are same. So then P is pressure, M1, L minus 1, T minus 2. Is it correct? Pressure will put that directly like this. This is V is volume, L to the power 3, then square is there. So it become L to the power 6. So this is mole, this is square. Then you find it. What is coming at last? Tell me. M1. L to the power
T minus 2 mole minus
L5 T to the power minus 2 mole to the power minus 2. Correct? So this is a dimension. 100% this question comes in exam. Always this question comes in exam. Okay, another question I'll give you as only homework. You just practice that question and you will solve it. I hope all of you completed this one and also understood. Another question also. These questions always comes in exam. A is equal to B plus C by D plus E. A is energy and D is suppose the momentum. Momentum, you know, mass into speed. Momentum, everybody know, mass into speed. right? Or you don't know what is momentum? Momentum, you know or not?
Yes, sir.
Okay. Okay, still I'm writing here. This is the momentum. So this is the question. A is equal to B plus C by D plus C. A is energy, D is momentum. Question is here, find the dimensional formula of other quantities like B, C, and E. Find the dimensional formula of B, C, and E. So this is the homework for you. Okay, again you will use that principle of homogeneity. Two statements you will use. Where they are added, they have same dimension. And each term also has same dimension. Okay, must do it. So again in the next, we'll discuss about the applications of dimensions.